testing definitions, role of testing, key processes, test processes, embedded software, embedded system test methods and levels like unit testing, integration testing, acceptance testing, and their definitions, and what are those, and regression testing. All this we had an introduction session. In the next session, it was about test case design and procedures with example procedure test case, how it is designed, what is the template, those things we studied. Also we studied about the testing standards, what should be used and how it should be used, test philosophy, what is V&V, debugging, test planning, example test plan, how the planning should be done. The recap of the next session: example test specification, example test spec, test procedure example. So we studied about those. Also we had gone through a sample SRS. I think I shared a sample SRS of a simple embedded unit instrument. Maybe we can touch base with that again during our exercises. That SRS software requirement specification talks about different modes of operation that embedded unit does, and an example scenario also we underwent during that session. Okay. In the next session, we studied about levels of testing, unit integration, and system depiction, and system depiction, test harness, about test setup, how tests are done, and how they are set up, and we studied about the host and target based debugging and testing from developer perspective as well as tester perspective in the initial stages of the software lifecycle. And also we came across a simulator, emulator, target monitors. So these are some of the testing setups, how they are going to be used in different levels of testing, like it could be unit level or it could be integration level or system level. And we listed out a sample test tools. What are those with an example, and this will be the basis for our next session. So how we are going to formulate all those tests based on this platform. Okay, then in the next session we studied about TM method. This is one of the structured testing method. Its overview, little principles that are life cycle techniques, infrastructure organization, how TM method is defined. Then we have categorized the commercial tools and a snapshot example also. In the next session we studied about the software life cycle, entry and exit criteria of the different life cycle phases, with an example of a prototype life cycle, formal life cycle, we defined it, and software testing life cycle also we studied. We took example of V model life cycle. Typically embedded industry they follow V model life cycle and its processes and elements. And also in the next session, the session 9, we studied about what are the process elements, and we took an automotive testing process, and consumer electronics life cycle example we had a walkthrough. And different types of life cycle also. Basically, it's an extension of the V model life cycle. The listed multiple V model, testing by developers, testing by independent testing. Then last session, session 11, we studied about master test planning. That means for a bigger or complex systems, how we are going to test, how we are going to plan the tests. That is nothing but master test planning. 10 principles of embedded software testing based on the art of software testing also we just gone through. Those are all going to be helpful in terms of understanding the next level of how to do the test and what are the different types of tests. So these are about recap of different sessions that we had in Unit 1. So unit 1 is all about fundamentals, understanding templates, standards, process, etc. Okay. All right. Okay. So in this session we study about the testing method and its details. Okay. To start with, let's study a little about IVND. There is an important term that is used in the industry. It is nothing but independent validation and verification. Uh, there is a dedicated team. They do this activity in a typical embedded software development and testing. There is a IVND team. As I said in my earlier sessions, there is a plan, execution strategy, execution team, who has to do what and all that. So all this comes under IVND concept, IVND terminology. So why it is called independent validation verification is there is a dedicated team. The testing has to be done with independence so that some of the uh, embedded software development or the testing mechanisms are all will be done in an independent manner so that it is not biased. Okay, so what is verification? So the basic difference between verification and validation is, are we building the product right, and the validation is, are we building the right product. So two things are there. Here product means the embedded software. First, as per the requirements, the product is in built. That's what is verification. Validation is the product once we develop, are we building it right? That means whether the product is acceptable from the customer perspective. So we are going to validate that. So these two are very important terms. The process of demonstrating the product built is right. So on the left hand side you can see the verification concept. On the right hand side you can see the validation concepts, and its differences you can compare it. Verification, it is a process that is used to evaluate whether or not a product, service or system complies with regulations, specifications or conditions imposed at the start of the development phase. That means basically verification takes care of the development aspects also, like whether the life cycle that is followed during development phase, whether it is complying to all the regulations, uh, whether the product or the process or the service that are used or the conditions imposed during the development phase are in line with what is expected. All this will be evaluated under the verification activities. Whereas in validation, the process of establishing evidence that provides a high degree of assurance that a product, service or a system accomplishes its requirements. That means we validate once these things are in place, whether that is meeting the needed requirements is what we are going to validate under the validation activity. As I said, the process of demonstrating that this is the right product is what validation does. Okay, the next one is verification can be development, scale up or production, which is often and process based. So basically as per the process could be anything that is going to be defined within the organization, how it is going to be developed and tested. So all these aspects will be verified under the verification plan. So this verification can also be part of development, whereas this often involves acceptance of fitness for purpose with end users and other products based. That means from the acceptance perspective, the product is validated. Example of verification is the model testing, requirement based testing, integration testing. That means all the primary inputs that are used are going to be applied for verification purpose whether the product that is built is correct, is what is getting done under the verification. Whereas in validation, example is that system testing carried out from the end user who is going to use the product. That means the product is built right, that is the right product. I mean, what is needed for the end customer is getting done, is going to be validated. So all these aspects, verification and validation, are done with independence because it should not be biased. That is the purpose of IVND. Okay. Now there is a term called static testing and dynamic testing. What are those? So let us define about dynamic testing. So we will understand what is it. Then we will, in contrast to that, how static testing is done. So that we will know the differentiation and how both are important. We will study about it. Okay. So what is dynamic testing? Definition: a process of evaluating a system or component based on its behavior during execution. That means testing done during its execution is called dynamic testing. It's as simple as that. We will put that unit under execution and put the unit under test while it is executing the program that is intended. That's a simpler definition. Another definition is testing by executing the program with real inputs. That means we do the testing while the system is under execution or the system is running the intended program. That is the definition of dynamic testing. The other method in context is static testing. That's what I was telling. This testing is done without the need of execution. So basically, we do the dynamic testing first, conclusion of all the real codes provided to the test, provided to the system, and we collect all the outputs and all that. Along with that, it may not be sufficient to have just dynamic testing alone. We need to have a static testing also. So that doesn't require any execution. So this includes software inspection and some forms of analysis. So basically, analysis, inspections, reviews, and all are done under the static testing. Sometimes some scenarios or the test cases that we have defined, it may not be possible to test it when the program is running or executing. So we may have to do some sort of a analysis of the program that is running underneath the target, or we may have to inspect the code, or we may have to analyze some of the results that we have captured. So with all that, with the help of that, we will arrive at a conclusion that is all under static testing. So that is the definition of static testing, dynamic testing. Static testing we don't need to execute. Dynamic testing is done when the program is executed. Okay. Dynamic testing, in continuation of the definition, there are two types we can categorize in dynamic testing: explicit dynamic testing and implicit dynamic testing. What is explicit dynamic testing? So in explicit dynamic testing, the most of the system's functions are tested by means of test cases specifically designed for that purpose. That means it is basically test case driven. With the help of test cases, it is specifically designed for that purpose to test it. That means explicitly we will test it with the help of test cases. In implicit dynamic testing, what we do is during the test process and execution, the metrics are analyzed to conclude on the specific testing scenario. That means while testing some methods or some strategy, we may come across some of the execution details or some outputs we may get it partially or fully. All these are used in terms of testing or test process that will help in concluding the specific test scenarios. These are all implicit dynamic testing. That means testing aspects are done implicitly. We don't have a specific test scenario for this. While doing some of the explicit test scenario, we may come across testing outputs, which is enough for arriving or concluding the outputs. So that are all part of the implicit dynamic testing. So usually most of the systems functions are tested by means of test cases specifically designed for the that purpose, basically for testing. So to this end, many test design techniques are available. We will discuss about that in later sessions. Testing can also be done by analyzing metrics, as I said, that is all implicit testing, or by assessing the initiated measures on the basis of a checklist. That means, as a conclusion of explicit, we might also cover some of the other scenarios. Those are all part of the implicit testing. For example, performance can be tested during the testing of functionality by measuring response times or memory with the help of some of the inbuilt tools. So we may not need a separate test scenario for doing these kind of tests. So no explicit test cases will be designed for this. So it is tested implicitly. That is why it is called implicit testing. Another example is security. For instance, can be tested statically by reviewing the security regulations, security aspects of how it is implemented, how it is behaving. All this can be tested implicitly. So that is about implicit dynamic testing. Okay. The next one is structured basis testing. We know that we have studied about TM method, applying the NATO principles of life cycle infrastructure techniques and organization. These principles are called structured approach. So dynamic testing is one of them. So we apply the structured basis methods for doing the dynamic testing. So similarly, any other testing approaches to align with the test process well defined in the beginning of the embedded software testing is all coming under dynamic testing. Okay, now coming to static versus dynamic testing. In software development, static analysis and dynamic testing are two different ways of detecting defects. We know that. Unfortunately, there are too many thoughts of completion are complementing each other, and developers are sometimes encouraged to favor one of the exclusion for other one. Like some people prefer static, some people prefer dynamic, that way. So what will happen is we need to segregate between static as well as dynamic when we draw the plan or when we do the strategy. Also we need to define the tools, so that are very much important. There are tools for static analysis also. So segregation of test strategy in alignment with development aspects, or the development team also, because we need to be in consent with the team also, because they are the one who will develop the system, and we should provide sufficient inputs, or they should be knowledgeable enough in the sense that how this system can be tested, so that testing goes smooth. So in that aspect, we will clearly define how much of the testing I will cover with the dynamic testing, how much I can do with the static, and what are the tools, static testing tools that I will use, and dynamic testing tools, so that the development team has a gist of what is getting done during the testing. So this will be clear in terms of any inaccuracy or harmful implementation that may be there underneath the developed software. So that will be a clear vision for the development team and the development process, and the role will be clearly defined, who is going to do what. So the team will be aware of what is going to be done. So two techniques basically they complement each other for static and dynamic testing. Static analysis were explicitly used in earlier days because we didn't have much tools for doing this dynamic testing. So most of the testing were done in terms of its intuition and reviews. So that is what is all static analysis. Either tools were expensive or availability was not there or limited licenses. So all these were some of the reasons why we didn't have much techniques for dynamic testing. So we used to have more of a static testing. So now we do a lot of automation, a lot of tools are available for doing the testing as much with a minimum intervention of humans. That is where the dynamic testing is growing. But still it may not be enough to have a dynamic testing. Someone needs to do a static analysis. Okay. So now we will having understood what is static and dynamic testing, we will go in detail of dynamic testing. Okay. So dynamic testing is further divided into basic groups. We know that black box testing and white box testing. Okay. Now can you pause please? Okay. So dynamic testing is basically divided into black and white box testing. We will study about each of them. As I said in my earlier sessions, black box testing is something like we don't need to know the finer details or the structure of the implementation or the programs which are part of the embedded software. Whereas in white box testing, the internal details of the embedded software will be detailed for testing purpose. Also, we study about black box testing techniques and white box testing techniques. So these are all part of the dynamic testing. Okay. Basically, for doing dynamic testing, black box or white box, whatever techniques that we want to apply, we need to have these things minimum taken care while doing the black box or white box testing. First thing is the strategy that we need to have it for doing the test. Next one is the test case selection. That means once we work out the strategy, once strategy is in place, we need to select the test cases. How are we going to pick the test cases? How are we going to add test cases more and more or less, whatever. Then finally we are going to have a coverage. How much the code is covered or how much the functionality or the requirement is covered. So these three aspects have to be there part of the dynamic or dynamic testing, which could be black box or white box. So we need to have a strategy. The strategy will define the purpose, the goal, and how to reach that goal. Once we have the strategy, how to attain that strategy is what we have to define under the strategy. It could be a performance related, or it could be a functional related, whatever it is. So basically, specification we know the system, we have understood and analyzed the requirements. Now it is a time for us to define the strategy. Once we have the strategy broader level defined, we are going to define test cases for each of the strategy per requirements. Under the test case selection methods, we have how to pick up the test cases for each of the requirements or group of requirements, or it could be functionality or features. So we will select the test cases, or we will define the number of test cases. So I am going to pick. Then once test cases we have defined for all these requirements, we have to group it, because we are going to write the scenarios. The scenarios could be covering different test cases, one test case, two test case, whatever it is. It could be multiple test cases also. So for simplicity sake, I will write it, so it will be easier. One or more test cases can be part of the scenario. It is basically driven from the features or functionality perspective, and purely this drives the grouping. Once we have the test cases, so what we do is just we define the test cases, one set of complete test cases for each requirement or functionality or feature, whatever it is underneath the defined embedded software. Then we are going to segregate whether they can represent good enough for all possible test cases. All scenarios can be done, or can we eliminate some of the test cases? Can we do a implicit testing with the help of explicit testing methods? All this will be under test case selection. Because why this is important is we cannot be writing test cases just like that for a requirement. A requirement could be talking about 100 test cases. That doesn't mean that all 100 test cases need to be tediously defined and tested. So it could be some 10, 5, 20, whatever it is. That is again depending on the test selection method. So we need to be doing a good selection of test cases and methods. Finally, once we have the test case selections, we are going to have coverage. So I repeat, the strategy what we do is we deal with defining the problem of the test to clarify the purpose of testing, then define a goal, and finally we develop the strategy how to reach that goal. Once the goal has been defined, a test case selection strategy can be constructed. We are going to construct the strategy wise test cases. The obvious strategy would be to test everything, that is there always, but the possibilities, like as I said, we cannot have an infinite number of test cases as it grows. It is based on the strategy how we are going to select the input, or if it is not feasible, we are not going to select those things. It is subjective again, based on the functionality of the feature or the limitations that the system has. So we need to be carefully selecting the test cases that are going to be executed eventually. These test cases should be good representatives of all the possible test scenarios. To simplify the selection, there are a large number of test case selection methods are there. Most of them are associated with the coverage criteria, or how we are going to make it a feasible completion of the test. So basically, to determine if we can discover failures or we can stop the testing. I mean, basically stop means here there is a sampling criteria. If out of 10 tests I can have a stop criteria saying that fifth test, if 5 failures are there, I'm no more going to continue, because those 5 failures are very critical and those need to be fixed before I take up the next, something like that. So coverage is a measurement of how much has been done compared to the total number of work. So that is what we do with the coverage. Okay. Now we come to test case selection methods. In black box, the selection method is basically functional or data driven. That is the real input. What we are going to use it is what is the criteria for test case selection. So based on requirements, functional specification, interfaces, or system specification as needed, we are going to have the selection. Black box test design techniques are based on the functional behavior of systems without having any explicit knowledge of the implementation sense. As I said in earlier sessions, the user or the test designer will not have any knowledge about the internal details. He knows is the box, that is the embedded system, what it is supposed to do, what is the specification, how it can be fed with the real inputs, what is the expectation, what is the output that he can expect. So in black box testing, the component is subject to input and the resulting output is analyzed whether it conforms to the expected results of the behavior. So in white box testing, the test selection is purely based on the structural or the logic that is implemented within the software. So based on the implementation or the structure of the code, we are going to try the test cases, or we are going to define test cases or the selecting test cases. White box test design techniques are based on the knowledge of the component's internal structure and uses all the information about how the inside of a unit works. That means what are the different components of the units that are there and how they interact, how it can be driven, how it is going to result. So all these micro level details are part of this white box test case selection. So this information might be code or design. So sometimes the code may not be enough. A well defined or well designed document also will be used for defining the white box test cases. White box tests ensure that each implemented test statement is run at least once and are tested against correct behavior. That means the implementation of the code has to be run or executed at least once, and with that execution we are going to test it against some behavior that should be correct behavior. That is what we do with the white box. So these are some of the aspects of test case selection for black box and white box. So we know that what we do is for the test cases that we have selected, we are going to have inputs that will be determined. Then the next step is to define the expected output for each of these input. So all test cases always take the expected output from the requirements for that particular input to find out how the object under test should react to the particular input. So we will have, I think I have explained in earlier sessions, we have an input, we have conditions, we have an expected output. All this will be laid out. So this is a standard, we use it for basically black box or white box. It doesn't matter because our test case design is such. So we have input, we have conditions that are required to trigger the input, then we have the expected output. So this is the basic thing that we are going to have it for test case design. Okay. So basically we use the logic here in white box, whereas in black box we use the specification or higher level requirements. So that is about the test case selection. Here is a diagram which clearly identifies the black box and white box testing, how it is going to be used. I mean, we know that component level testing is there, integration testing is there, system testing, acceptance test down the line, and as an embedded system we have to cover it. So it will be covered 90% or 90 to 99% with the help of black box and white box. There are cases where we use gray box, it is called. I'll just put few words, but we will not concentrate on the gray box. It is a mix of both black box as well as white box. This is an interesting thing actually. I will explain in detail. We know what is black box. We know what is white box. The two types of test cases are used a little bit differently in the development cycle. White box test cases are mostly used in the early test cases. We know that of the development cycle, and are of less usage higher up in the testing hierarchy. And black box testing techniques are used throughout the development life cycle. That means we always focus on the black box level. The main advantage with the black box testing is that the only depends on the requirements, whereas the white box purely depending on the low level design and implementation. So both methods are of course important, white box as well as black box. However, there is a boundary between these two. So a gray box tester partially knows the internal structure, which includes access to the documentation of data structures as well as the algorithms, some sort of final details of the implementation will be part of the gray box testing, and he is also knowledgeable enough at the higher level. That means the detailed documents in terms of specification, describing the end application, what is going to be running on the field. So all this will be part of the black box. So the gray box tester will also have knowledge of that. So gray box testing sometimes are applied explicitly, but it could be defined underneath white box itself or black box itself. But just for a definition sake, it is beneficial because it takes the straightforward technique of black box testing and combines it with the code targeted systems in white box testing. So while doing the black box, we have a fair idea about what is happening within the white box, that is the implementation of the code. But generally I have seen not much used in embedded systems industry. They don't have a separate definition, though they cover it while doing the black box or the white box. Usually it is used in I would say object oriented software systems. Mostly it is used. So it has both a mix of black box as well as the white box strategy. So let us not concentrate much on this strategy. It is at this definition is a combination of both. Just for the definition sake. Okay, so we understood what is black box, what is white box while doing the dynamic testing. Now coming to the coverage, it's a very important thing because at the end of the day, after completion of the embedded software testing, we need to be knowing how much we have tested. So without that, testing is not complete. So what is white box testing coverage? What is black box testing coverage? Code coverage is what is that called as white box testing coverage. Basically, it measures the code coverage in terms of how much execution I have done during the white box testing versus the total coverage. So basically, it is a executed code divided by total code will give the code coverage in terms of percentage. The coverage is different in terms of percentage. Similarly, here also the coverage for black box testing is measured purely this is based on the requirements. So how much of the requirements have been tested versus or divided by total number of requirements will give me a percentage of cover, how much I have covered. Suppose for example we take both of them will define there is a 1000 lines of code, that is a denominator, and we have covered say some 7500 lines of code. That means while doing the black box testing we have covered the 7500 lines of I'm sorry 750 lines, or you can say 10,000 lines. Suppose it is 10,000 lines, it will be 7500, then it will become something like 75%, right? So that is the code coverage I have. So 25% I would have covered or I would not have covered. So what are the techniques that we can cover? That all we will study while doing the white box testing techniques details. So we use for white box testing tools such as Cast, RTRT, but it may not be possible to cover 100% with the help of that. So we have to see the other techniques in terms of coverage. So those coverage aspects and all detail later. Okay. Similarly, coming to requirement coverage, I have say 100 requirements and I have covered 80 requirements. So my percentage of cover is 80%. So 80% I have covered. The 20% of coverage we need to see how that is called as coverage shortfalls. How I am going to cover these shortfalls? That is 20%, 25% for white box, and 20% for black box. Okay. So there are different techniques that are used for coverage shortfalls. Like we could take a credit of white box for black box. Similarly, credit of black box for white box. That means to say that some of the requirements which I cannot cover in black box, I would have covered with the execution of that particular functionality. So I would say I have covered in terms of error-free code, so that it doesn't harm. But it's suggested not to have this thing. The best way to have techniques defined for shortfalls, so which could be inspection, analysis, reviews, etc. Of course, while doing all this, we might look into some of the results that we have achieved doing the white box while we are doing the analysis of the black boxes. The other way also is true. While doing the white box, you might have to take a credit of black box in terms of inspection, analysis, etc. So that will be used in terms of the complete coverage. So the ultimate aim is to cover 100%. Without 100% testing is not complete. So we should be telling that I have covered 100% of the requirements, or I have covered 100% of the code that is tested. So then only the product is called as embedded software testing completed. Okay. The next one we will see a difference tabulated here. Black box versus white box system. So also called black box is also called as input output driven testing or specification based testing, whereas white box is called logic driven testing or implementation based testing. We know that white box is taken or done with the help of the implementation of the code, and software is viewed as a black box without bothering about the internal behavior and structure of the program in the black box testing. Whereas in white box testing, we need to analyze the internal behavior or the structure of the program or the code. Software is tested against its specification. Software is tested against low level specification, or it could be design, also called as a detailed design or low level design. Also, we use the code as a knowledge for white box testing. Test data is derived solely from the specification. So we have the test selection or the test data defined based on the requirements of the specification, whereas the test data is derived from the logic of the program. That is, we will understand the logic of the code that is implemented. Based on that, we will arrive at the test data. So these are the differences between black box and white box. We will see advantages and disadvantages of each methods that we have for black box and white box. Okay, so what are the advantages of black box? So black box tester no need to have a connections with the code. He doesn't have to care about what is a code, but all he has to care or his perspective should be code should have bug. That means he should suspect always seeing that the code will be having some issue. That is why it is failing. That should be the intention of the motto for a tester, to see to that he is testing the embedded software or the embedded system with that intention. Test cases are designed as soon as the specifications are complete. So he don't have to wait for the implementation to complete. He can test it as soon as the requirement is done. No need to wait for code or implementation to complete, because we know black box, so we don't need to bother about the internals. All we bother about the requirements against what the product is being developed. There is a need of having detailed functional knowledge or system of the system to the tester and its behavior. Definitely, this is one of the important thing that I have spoken last time. The tester should have a sound knowledge equally to the development team. That means tests will be done from the end user perspective. So definitely he needs to have a the end user point of view, and he should have a sound knowledge of the system of the test. This is why, because the end user should accept the system. Basically, without the knowledge, we cannot test it. So to understand a system, the best way to do is do a black box test. So these are the reasons sometimes this testing technique is also called as acceptance testing, because the product can be accepted or not can be told only in the testing mechanism of the black box testing. So black box testing also helps to identify the ambiguity and any contradictions in functional specifications. That means it will bring out if any interconnected requirements or any ambiguity is there. All those aspects will be identified. It means say whether requirements are complete or no ambiguity is there, or it is correct. All these things will be tested, in the sense that when we have a larger system, the basic specification is subdivided into subsystem requirements. What will happen is since these subsystems are developed or specified with different people, uh, there are chances that there is a disconnect between these subsystems and its developers. So all this will be identified with the help of black box. Sometimes while writing the test cases itself, we will come to know there are problems with the requirements, that the requirement is contradicting to the other requirements, or it is having an ambiguity in terms of its completeness, or the requirement is not completely written such that it can be tested. So other aspect of the requirement is that requirement should be written such that it can be tested. It's a very important thing that the developer has to take care. So these are some of the advantages of the black box testing. So why we need to have all this is because it is useful for the or the efficient for the larger or complex systems. Okay, so that is about the advantages of the black box testing. Black box testing disadvantages. There are more advantages. Equally, it is having a disadvantage. But we'll see how to overcome all these things. Testing with every possible inputs is unrealistic because it would take inordinate amount of time and tedious. It means sometimes those specifications says the system should accept so and so signals, and it should tolerate so and so temperatures or the ambience, whatever it is. So what will happen is it may not be possible to feed all those values. It may be difficult, or the those situations may not arise, but it can so happen that we may not be able to feed the values. Unrealistic situation is very difficult to emulate. And black box testing mostly it doesn't care about the structural and decision coverage. So if something is there, what is going to happen? If something is not there, it is also called as else portion of it. What is not going to happen? So that portion of it may not cover sometimes. Why? Because we are going to go purely by the requirements, especially if then else kind of requirements we may not be able to test it completely. Exact that is specifically for the code actually, but sometimes requirement also have to specify if this condition occurs, this has to happen. If this condition doesn't happen, that is the else portion of it. So what is going to happen? So that is all sometimes will be part of the code, but it is good to have requirements identifying all these things. In that case, it is easy to do the black box testing, but black box testing doesn't care about the decisions or the structural coverage. Exact point in the code where the software malfunction is that cannot be detected. That means we may not be able to. Sometimes it may hang, or sometimes it may not behave the way it should. We don't know what is the issue while doing the black box testing. So though we say as a failure, we may not be able to arrive at a analysis of where it is failed. So it is because it is due to the implementation issue. So in that case, we may have to do a inspection, code inspection, where the faulty code is there, fault code is this. Reasons for intermittent failures of the code cannot be determined. That means this is a very typical thing actually in the embedded systems. What will happen? We may not be able to reproduce some of the failures. It is very difficult. Sometimes the failure occurs, sometimes it doesn't. How do you find out? So those cases also it is difficult to do a black box testing. Is a disadvantage. We know the failures are there, but to make it point where it is going to fail, it may be difficult because it varies, as it's told here, whether user required functionality is implemented exactly or not. We don't know until we discover with the help of other methods. Okay, the next disadvantage is that some of the errors may not be able to discover until the white box testing is done. So, as I said, so all these disadvantages may require to do a white box testing. With the help of white box testing, we might analyze and come to a conclusion why it is failing at the higher level. And the last disadvantage is that heavy dependency on the test environment and stable system. So it is very important. We need to have a very predictable and dependent stable system. So such environment we need to have it. So that's a challenge. So that is why we have a heavy dependency of this for the black box testing. Okay, so now next thing is we move to white box testing advantages. As the knowledge of the internal coding structure is prerequisite, it becomes very easy to find out which type of data input we can provide. So what are those applications that can be tested with the help of that. So all this will be easier and efficiently we can test it. And white box testing techniques helps in removing the unwanted lines of code. That means we know what lines of code is responsible for what functionality, what is not responsible, what are the defects that we have underneath the program. All can be discovered with the help of white box testing. Sometimes, for example, faulty code segments, it will find out the use of equal to, double equal to. There is a difference between that. So all this will be found out. If you use equal to and if you use double equal to for a couple of variables, the variable will roll out. That means that's called a rollout problem. There is a difference. One is for comparison, other one is for assignment. So definitely there is a chance that the intended purpose of that piece of code will fail. The next one is discrepancies between the code and requirements can be identified. That means it is equally important for the white box tester to have some knowledge of the requirements or a minimum knowledge that is enough for him to do the white box system, so that he can find the discrepancies. What is to be implemented? This is very much important, especially from the algorithms or conversions. Some of the ADCs, what is getting used, and representations, tolerances, because tolerances are defined directly in the requirements. Like it could be plus or minus some percentage, n percentage, for example. These are defined directly in the requirements. So it is good to have a knowledge of requirements, and we know what code should be there for that requirements particularly. So all this can be found out with the help of white box testing. Any errors are there. And for doing the white box testing, we don't have a system dependency. We don't need an end-to-end system or the actual end target, because the actual end target may require some signals. Those signals we can emulate with the help of white box testing with the values that we want to drive. So those are the advantages of the white box testing. Disadvantages of white box testing are as per below. As knowledge of code and internal structure is prerequisite, a skilled tester is needed to carry out the testing, because he needs to have a thorough understanding of the complete code what is going to test it. So basically this will result in extra effort and the cost. And white box testing is usually time consuming because he has to test from all the aspects and he needs to understand how the code is going to be compiled, and the code development environment he needs to have. Details that he needs to know because he will be covering the structure of the code and its implementation as per the standards that are there. At times there is a need of system knowledge for the internal details of implementation, especially the tolerances and different states of the software. So all this knowledge he needs to process. So that is why white box testing is a bit I would say is time consuming and lot of methodical efforts are required. So that's a disadvantage, but there is a dedicated team usually allocated throughout the testing life cycle of the white box testing for an embedded system. Okay. Next, we understood the white box disadvantages, advantages, black box advantages and disadvantages. Having understood the black box and white box testing terminology, these is under dynamic testing. Now we'll come to the test selection criteria for the dynamic testing of the black box. What are those? So equivalence partitioning is one of the test selection criteria. Boundary value analysis, state or event transition. These three categories are used for test selection criteria. We know that test selection criteria is based on different methods. For black box we have functional data driven. These are some of the inputs. So don't get confused with the methods and the criteria that we have for test selections. Equivalence partitioning, boundary value analysis, state or event transition. So we know the requirements, what are those inputs, how it's going to be tested. All this should be covered under one of the criteria, or we should have the criteria used for selection. These selections are primarily based on normal or robustness conditions. We will detail out all these things in the next slides, and it will be in the next class. As we complete this class, we will go through some of the words, embedded software testing or development words that we have added: SSIT, HSIT, and IVNV, independent validation verification, which is today, robustness. Any other words that we want to add, we can do it. I think white box, black box is not there. We'll take white box, black box, test selection. So these are some of the embedded software or the system words that are required to have an understanding from the tester perspective. Okay, so that is the conclusion of this class. Before that, I have a few exercise questions of this class. What is the difference between static versus dynamic testing? What sort of systems, the white box and black box systems, are advantages? Describe in brief. What are the selection criteria that need to be considered for black box system? How coverage is defined for requirements based system? Okay, so we will go to the next class with equivalence partitioning, boundary value analysis, etc. To recap on today's class, we studied about the methods of dynamic testing, black box and white box, its advantages, disadvantages, and grouping of that, and what is the test selection, and what is the coverage for white box as well as black box. Thank you.